Alright, so in the last set of notes, we did finding partial derivatives of a multivariable function. Find the first order partial derivatives. And so in this 7.2 part 2 section, we're going to look at the second order partial. So we're going to get second derivatives. Just like we took the second derivative of one variable functions, we can take second partial derivatives. Alright, so remember the function notation that I used for taking the first derivative was f sub x represents the derivative with respect to x. F sub y represents the derivative with respect to y, right? That's the variable that's changing, the sub. All right, and the other one is being held constant and therefore behaves like a constant, and we treat it like a constant. Well, we can find second derivatives. All right, so remember, second derivatives are the derivative of the derivative. And so we have two first derivatives, and we can take each of those derivatives with respect to both variables. So how many second derivatives will we have when we have a two-variable function? Well, the answer is 4. 2 for each of our derivatives. We get 4 second derivatives. Order derivatives. Alright, so remember the first derivative, the notation for the first derivative, I'll write that down. So the first derivative was the change in my function. I'll do function instead of z. Change in my function with respect to x was f sub x of my xy expression. My second derivative, or first derivative with respect to y, was again change in my function over change in y, f sub y of x, of the function xy. Alright, so what we do is we take a derivative of each of those. Right? So the second derivative. And so I take the derivative twice of my function with respect to x twice. Right? That's rate of change notation. Again, I will be using function notation mostly. And so this is the function notation. I take the function f, a really weird f, derivative with respect to x twice in a row. Right, that's what this notation means. I'm taking the derivative of my function with respect to x twice. Or I could take the derivative of my function with respect to x and then with respect to y. So in that order, that's why we use the term order. The function notation is x, y in that order. Again, that's the means. That's how I took my derivative. I took the derivative with respect to x first and then y. And that's our mixed derivative. Alright, so there's two of them. Right, using the first derivative with respect to x, and then basically we do the same thing with the first derivative with respect to y. Alright, I could take my derivative of my function twice with respect to y twice. Again, using function notation, it'd be f of y, y, f sub y, y. Again, it's the order. We took the derivative. I took the derivative of my original function with respect to y 2 times in a row. Or I could take my second derivative with respect to x, first with respect to y, and my differentials there are looking a bit like 2's. Alright, first with respect to y, and then with respect to y again. Alright, so the derivative of my function twice with respect to y, and then with respect to x. Sorry, with respect to x. In that order, y first, then x. And so the subnotation is f sub y, x of my function. Alright, and there are my 4. So there's 6 derivatives here altogether. 2 first derivatives, right? Those are my first derivatives. And then each of them have 2 derivatives, and so altogether I have 6 derivatives. 2 first derivatives and 4 second derivatives. And just a quick note, these mixed derivatives, right, now the way we get there is different because we go in a different order with our derivatives. But as it turns out, the mixed derivatives for our functions, mixed second derivatives, are equal. Alright, they should be the same expression. Alright, and when we do examples, I'll point that out when we get to examples. Alright, now again, the process is different. We go in a different order, but when it's all said and done, these mixed derivatives, the xy and the yx, will actually end up being the same. in all of our type of functions. Alright, so in the last set of notes, we actually found the first derivative of this function. This was one of the examples that we did in the last set of notes. Alright, so we have our function f of x, and so I'm giving you the first order derivatives. Again, we did them in the last set of notes. If you go back and look, this is one of the second set of notes that we did in finding this first order derivatives. Alright, now we want to find the second derivatives. Alright, so I find the derivatives of the derivatives with respect to each variable. So I'm going to start with my f of x, derivative with respect to x, and I'm going to take the derivative with respect to x twice. Alright, which means I'm taking the derivative of this function, which was the derivative of my original with respect to x. I'm just taking its derivative with respect to x, and then I'm going to take its derivative with respect to y, and there's my two second order derivatives where I get them from my first order derivative of x. Alright, so first the xx, derivative of x, twice. Alright, so again, I only take the derivative of x when I have an x part, and so this 5y squared will zero out, it's just a constant. And so I just follow my rules on the 12x squared, so I'm going to get 24x to the first. That's going to zero away. So remember, the 3 is a constant, the y to the fourth behaves like a constant, and so I'm going to write them down, as they're just constant multipliers, they come along. I take the derivative of the x squared part, so the derivative of x squared is 2x, and then I'll clean that up in a little bit. Alright, then the last one, again 2e to the 2x, so again this is going to require my chain rule because of the 2x. The first thing I write down though is the 2e to the 2x, but I'm not done yet. Alright, remember, times the derivative of the inside, so I have another 2 there. Alright, then I'm going to clean this up, and clean it up just means I'm going to multiply the 2x times the 3 and move it here, take this 2 times that 2 and move it to the front. Alright, so it simplifies to 24x plus 6xy to the fourth plus 4e to the 2x, and there's my second derivative with respect to x. Alright, still looking at this function. Alright, but now I'm going to take its derivative with respect to y. Alright, so I'm only going to look at the y part. So there's only two terms with y's. Again, this is going to zero away and that's going to zero away because there's no y part. And so it's just the negative 5y, which is 10y to the first. And then in the second term, the 3 and the x squared are just constants. They come along. I take the derivative of the y part, which is 4y cubed, and then I can simplify that. So 10y stays the same, but I multiply 4 by the 3 to get 12x squared, y cubed, and there is my second derivative with respect to x, then y. So my xy order, which this should be the same as when I get my next mixed one when it goes yx, and we'll see that it is. Alright, so there's using the f of x. I'm done with that function. Now I'm going to move on to the f sub y, the derivative of my function with respect to y, and take each of its derivatives. So with respect to y twice, and then with respect to y and with respect to x, which that one should look exactly like the one I have up here above. Alright, so first with respect to y, so I'm looking at this and taking its derivative with respect to y, so both terms have y's. So the negative 10x is just a constant that comes along. The derivative of y is just 1, so I'm going to leave it off. Alright, the next term, the 4x cubed, is just a constant. It comes along. I take the derivative of the y part, which is 3y squared, and again I will clean that up. Negative 10x plus 12x cubed y squared. Alright, now the mixed derivative, which like I said, it should simplify to that. Now we get there in a different way. Alright, because again, I started with a different function to get there. I'm taking the derivative of this with respect to x now. So again, I'm taking the derivative of f sub y with respect to x. And so both pieces have x terms. So again, in the first piece, the negative 10 and the y are constant multipliers. They come along. The derivative of x is 1. Alright, so again, I don't write the 1 down. In the next term, the 4 and the y cubed come along. I'm taking the derivative of the x part, and so the derivative of the x cubed is 3x squared. If I simplify that, now again, I get a different expression than what I had here, right? It's slightly different. But if I rewrite it and clean it up, my negative 10y is the same. If I multiply my 3x squared times my 4, I will get 12x squared y cubed, and it is exactly the same as that one. And again, for our mixed derivatives, that'll always happen. We'll get there a different way, but that will always happen. All right, so there are my 4 second order derivatives. All right, there's all 4 of them. All right, second derivative with respect to x, the mixed derivatives, and the second derivative with respect to y. Alright, so the next example. Alright, so this one we're going to find all of them. Alright, find the second order partial derivatives of the first function. And this one, I didn't give you the first derivative, so we actually have to find 6 derivatives altogether. Alright, the first thing I have to find is my first derivatives. Alright, those are my first derivatives. These are my first order derivatives. Right, we have 2 of those if you can read that, first order derivatives. Alright, so I'm going to find both of my first order derivatives, and then I'm going to do my second order derivatives. Alright, so derivative with respect to x of my original function. So again, I only look at the x values. That's it. Those are the only 2 x values, meaning everything else doesn't have an x value, therefore it doesn't change. So the derivative of 12x is 24x. Negative 52 is going to give me, negative 52x is going to give me a negative 52, right? Negative 52 is a constant multiplier. It comes along. Derivative of x is 1. Alright, done with the x term. Now I'm going to do the derivative of the y. Alright, the first derivative with respect to y. So again, I only look at the y parts, because I'm taking the derivative, and that's it. There's only those 2 y parts. Everything else will zero out, because there's no y to affect change. Alright, so just the 30y squared, which is going to give me 60y, and then negative 90. Alright, so now I sort of split it. Alright, I'm going to look at the individual derivatives. So I'm going to start off looking at my x derivative, take its derivatives with respect to each variable. Alright, so these are my second order derivatives. Alright, so again, I'm looking here. Alright, take the derivative of my c sub x with respect to x. Well, there's my x term, so 24x. It's just 24. The 52 will zero out. Notice there's no y term in that expression. So since there's no y term, when I take the derivative with respect to y, there's no change because there's no y to change it. And so my mixed derivative is just 0 in that case. Alright, so I'm done. There's 2 of my second derivatives. Now I'm going to find the other 2 looking at my first derivative of y. Alright, so I'm going to find my second derivative with respect to y. Again, only one y term, the 60y, so I'm looking here. Alright, derivative of 60y is 60. Notice there are no x terms there. Alright, so when I take the derivative of this function with respect to x, it will zero out, and see that my mixed derivatives can't. And I got there a different way, in a different order, but they came out equivalent. They both turned out to be 0 in this case because there are no x terms and y terms in my mixed together in my first order derivatives, and that will always happen if that's the case. Alright, next example. So again, I have to find my first order. So I'm going to find my first order derivatives first, and then find the second order of those. Alright, so first order with respect to x. So the derivative with respect to x, I take the derivative of x squared, which is 2x. No x in the y cubed, so that zeroes out. Negative 18xy, well, the negative 18y comes along because it's a constant multiplier. The derivative of x is 1. Alright, so there's my first derivative with respect to x. Alright, now I find my first derivative with respect to y. So again, the x squared, there's no y part, that'll zero out. Derivative of y cubed is going to give me 3y squared, and then the negative 18xy, well, the negative 18 comes along. X is also being held constant. I take the derivative of the y part, which is 1. Alright, so there are my first derivatives. Now I'm going to take derivatives of each of those. So again, I'm going to start with the x, and then I'll get to the y. Alright, so the second derivative using my x function. Alright, so the second derivative with respect to x twice. So I'm looking here. Well, there's only one x term. So the second derivative of that comes out 2. Second derivative with respect to y. Well, again, there's one y term this time, which is the negative 18y, and that's derivative is negative 18. Alright, there's 2 of my second derivatives. Now looking at the y function. Alright, so the second derivative of y with respect to y, well, there's the y term 3y squared, so I'm going to get a 6y, the negative 18x zeroes out. And then my derivative of that function with respect to x, well, the only x term is negative 18x. Derivative of negative 18x with respect to x is negative 18. And again, those mixed derivatives came out, now we got there a different way, but they came out the same. Alright, so there were my second order, so there's all 6 derivatives. 2 first derivatives, there's my 4 second derivatives. And what's nice about second derivatives, because remember, every time we do a derivative, we sort of simplify the function, right? We go from a square term to a single term to a constant term, right? And so the second derivatives usually aren't too bad. Alright, the last example. Alright, so this one's going to be a little more complex. Alright, so again, I have to find my first order derivative with respect to x, and then I'll find my first order derivative with respect to y. Alright, with respect to x, again, I'm taking the derivative of the x parts. So the 3y cubed is a constant that's going to come along, constant multiplier. Derivative of x squared is 2x. And then the natural log is 1 over what's inside. So 1 over x times y, but I'm not done yet. Chain rule, derivative of what's inside with respect to x. Alright, derivative of the xy with respect to x. Well, y is a constant multiplier that comes along. Derivative of x is 1. We actually did one either like this or very similar to it in the last set of notes. I will clean this up because I'm going to take second derivatives. Always clean it up before you take a second derivative. I'm going to multiply 2x times the 3 to get 6xy cubed. And then the y's reduce and leave me with 1 over x. Alright, so there's my first derivative with respect to x. First derivative with respect to y. Alright, so now I'm looking at the y parts. Alright, so the 3x squared is a constant that comes along. I take the derivative of the y cubed, which is going to give me a 3y to the second. And then the log term again is going to be a chain rule. It's 1 over what's inside. 1 over xy, but I'm not done. Derivative of the inside part with respect to y. So I'm looking inside with respect to y. So the x is going to come along. The derivative of just y is 1 again. Going to clean this up. 3 times 3 will give me 9, x to the second, y to the second. Same thing here. This x will reduce with that x, and I'll simplify to that 1 over y. Alright, so now I'm ready to take my second derivatives. Alright, so again, I'm going to look at the x first, and then I'll go to the y. So f sub x, and then f sub xy. Alright, just a reminder, the 1 over x, I don't want to use the quotient rule. Remember, I can rewrite that as x to the negative first. Same thing over here with the y. I could rewrite that as y to the negative first. And that's the easier form to take the derivative of. Alright, so keep that in mind when I'm taking the derivative. Alright, so looking here, taking the derivative of that function with respect to x. So 6xy cubed. Well, the 6 is a constant. The y cubed is considered a constant. So 6y cubed comes along. The derivative of x is just 1. So it's just 6y cubed. Alright, the second term is, again, we rewrote 1 over x as x to the negative first. So when I take the derivative with respect to x, I'm going to get a negative x to the negative second. I'm just going to leave it. If you want to rewrite it as 1 over x squared, you can. Again, I'm fine with negative exponents, so I'm going to leave it. Alright, now the mixed derivative. Alright, so the mixed derivative, so now I'm looking at this function and taking its derivative with respect to y. Alright, so in the first term, I do have a y cubed. Right, the 6x is just a constant multiplier. It comes along. I take the derivative of the y part, which gives me 3y to the second. 1 over x, there's no y in there, so it won't change, so that zeroes out. So that's what it is. And again, I'm just going to simplify it by multiplying the 3 times the 6 to get 18xy squared. Alright, so there is my second derivatives with respect to x. And now my second derivatives, with my f of x, so with respect to x and with respect to y. Alright, now the y function. So now I'm looking here. I'm taking its derivative with respect to itself, and then the mixed derivative. Alright, so looking at this function, taking the derivative with respect to y. So the 9 and the x squared are just constants. They come along. I take the derivative of y squared, which is 2y. Same thing's going to happen here. I take the derivative of the y to the negative first. So I get negative y to the negative second, and then I'll rewrite that down here. I can simplify this to 18x squared y minus y to the negative second. Alright, and so there's the second derivative with respect to y simplified. Alright, then the last one again, it should simplify to 18xy squared if I do it right. Alright, so again, I'm taking the derivative of this function with respect to y, or sorry, I wrote that backwards. Y then x, right? Order matters. Alright, so do make sure that's written the right way in your notes. It should be y then x, right? Taking the derivative of this f of y function with respect to x. I don't want to redo this one. It should turn out to be the same as that, but we are doing it in a different order. Alright, so this is the order we're taking the derivative. Alright, so looking at this function and taking the derivative with respect to x, well, that's the only x term. Right, the 9 and the y squared comes along, so 9y squared comes along. I take the derivative of the x part, which is 2x. And then if I simplify that, I do get 18xy squared. And there it is, exactly the same as that. Alright, so there are all of my derivatives, all 6 of them. Right, my first order and my 4 second order. Now in your notes, if you printed it off or looking at the handout, I said I was going to do book problems, but I went ahead and put those in they're just practicing finding second order derivatives, so hopefully, again, if you understood today's notes. So I went ahead and put those problems in the Connect homework. Alright, so if you go to look at the Connect homework for 7.2, these problems are built into it. And so go look there and practice finding first order and second order derivatives. Alright, so that's where we're going to wrap up today's notes. We're going to get into, after this, some marginal analysis. Right, that's the last thing from this section, is looking at your first order derivatives, interpreting them in terms of marginal analysis. Alright, so that's the next set of notes. I'm going to stop there.